Hey guys, it's Marty with DPC Technology. We're here today to talk a little bit about terminating cables. We're going to make a cable, just a regular patch cable, so we'll show how to terminate a cable with male ends and kind of talk about the wiring standards that go into that. And then we'll switch over to a wall plate over here on the wall next to me where we'll go ahead and terminate a female end or a keystone end and kind of show you the differences between that, a couple of things to look out for, and how to pop that into a wall plate and mount it to the wall. After we're done terminating both of those cables, we will use a set of testers and test to verify that cable is good to go. I will also show you a couple of features in that tester that may be useful down the line, usually for a network guy, not necessarily for a home installer kind of person, but for instance, how you can plug into a patch panel and find a cable that's downstream when you have 100 cables in your building, something like that. A couple of things you're going to need. Die cutters, that's how I cut this cable this length. We probably don't need them at this point, but maybe useful. Set of strippers. We have a couple of male ends, a keystone end, or a female end rather, however you want to refer to that. And I have a set of crimpers I'm going to grab here in a second for these male ends, but this is the keystone punch down tool for the keystone itself. So first and foremost, we'll make just a regular patch cable, which means we need to put a male end on each end of this cable. Now, I'll be honest, a lot of times these days, we just use prefabricated patch cables. We do this because making male ends, or terminating with male ends rather, can be a little tedious, certainly more so than terminating with a keystone. But if you find yourself in need of a custom length patch cable, that's a scenario where you go grab yourself a box of cable, cut 12 foot of cable, and let's terminate ends. Whenever you make a patch cable, or you're terminating a cable with a male end, how far you strip back the cable is gonna give you a little more or a little extra work. Now, if you're just making one of these, it's not a big deal. But I'm acquainted with a scenario where I may be terminating 50 or 100 cables and your fingers get sore. So one thing I like to do, and I'll use a bad example first, is I don't like to strip back too much cable. So if I do that, right, I have all of this cable. Now, you can see that with a male end, I have twice as much cable here at a bare minimum than I need. If I was doing a keystone, that would be different, and I'll come back to that later. But the point is, with a male end, we want the length of this exactly right, because we're not just gonna cut the excess in the same way that we would do it here. We will cut the excess, but anyways. Point being is that I have to untwist this. And if I have to untwist it 2 times, awesome. If I have to untwist it 4 times, well, that's twice as many. You get where I'm going. And there are 4 pairs here. Again, if you're doing a ton of them, that will add up, and I have had sore fingers, just blisters on my fingers from untwisting stuff for several hours on end. In this, you will notice, and this is a piece of Cat 6 cable. Cat 5 cable won't have this plastic center channel, but in a Cat 5 or Cat 6 cable, you will have the same 4 pairs. They're all colored in the same way, and that is an orange-white pair, a green-white pair, a blue-white pair, and a brown-white pair. There is a very specific order to line these up in if you want to adhere to the standard. If you are making your own custom patch cable and you just want to be a goofball at the house and wire these in some random obscure order, as long as you do it the same way on both ends, that'll actually work just fine. But there are 2 standards. There is an A and a B, and basically everyone uses B. If you're ever wondering why there were 2 standards, the one reason I can tell you that I'm aware of is if you were ever alive in 2003, hanging out with your friends with 2 Xboxes and 2 copies of Halo and you wanted to play multiplayer, you can make an uplink cable, which means you have to have one end wired in A and the other end wired in B, also known as a crossover cable. But these days everyone uses switches and they're on the internet and you only have to deal with that these days. So pretty much all cables are terminated in B when it comes to networking. If we strip this down this far, the first thing I would do is grab these die cutters or whatever type of cutters you may have and just cut that center channel, that little plastic channel, because it'll get in the way. And from there, I start sorting these in the way that I know that they're going to go. So orange is on one side, brown's on the other side, and your green and blue are gonna be split right there in the middle. Just untwist these till they're nice and straight and they're laying flat. And the first pair is orange-white-orange. First 2 wires on a cable is going to be orange-white as pin 1 and orange as pin 2. So I grab these, untwist these, and you can see that they are untwisted all the way back to the sheath there. So I grab them, kind of pull them, pinch them, all this little goofy stuff, just make sure they lay nice and flat. Because what I'm going to do when it's all said and done and they're all laying flat, I'm going to cut them to the length I think is appropriate. And if every single pair, as you go along, you untwist nice and you stretch out and you flat and you shuffle and you make sure they're laying all flat, they will go into this end much, much easier. If they are different lengths at all, when you go to shove them in there, they'll bunch up and you will quite possibly have a bad end. So after we do our orange, white, and orange pair, we grab our green, white, and green pair, and then we grab the green, white, pull it off to the side, Like I said, I lay them flat, squeeze them, pull them back and forth, make sure they're not laying nice and flat. But my green wire goes off to the side because it's not pin 4. All right, so kind of going back through here, we have orange, white, orange, green, white, blue, blue, white, green, brown, white, and the last pin is this brown. Previously kind of grabbed those wires, laid them nice and flat, squeezed them back and forth, and was ready to cut and then let go of them just to go grab a tool. And just wanted to show you guys, this is what we're left with, which you can look at it and you see that it's in pretty good order. But when you come back to it, you need to grab it, pull it and squeeze it and make sure it lays all flat. And I say that because that just helps get every single wire here to be the exact same length. And we do that because when we go to cut it, it should still be the exact same length, right? And I never let go of this pinch I have in this left hand. I just cut it with this tool, set this tool down. I never let go because as soon as I do, they will come out of order. At least they have the chance to. So while I still have this cable, still nice and flat, kind of grab it, push it in there. And as I push it in there, what you're going to see is that you see these things fall into little trays or little slots. And as soon as you get it started, they will follow those slots. And if you did everything perfect, the sheath is almost flush with the end of this male end. And what we want is we want it to come past this little notch right here, because this crimper tool, one thing it's going to do is it's going to hit all these little pins in the end and pinch down or squeeze down and poke down into that wire and make contact with the copper. The other thing it's going to do is it's going to crimp the wire itself. It's going to squeeze it in here so it can't pull out. And if you don't have the sheath up far enough along the wire and into this connector, it will not do that. So one thing I always do is after I've done all that stuff and I've got those cables lined down on that tray, I will grab the sheath and hold on to the end and purposely try to slide the sheath over the wire and down into the connector. Now you can see that sheath is almost all the way into the little area where the trays go, which is as far as it can go. If you get a little side angle right here, you can see that that void gets really small and it's only big enough for the wires themselves. So as far as I'm concerned, we're good to go. Now that we have all those in there, grab our crimping tool. Most of these crimping tools have a spot for Cat 3 and Cat 5, and I just pointed to this backwards. So that's actually Cat 3 and Cat 5. When I say Cat 5, it's also Cat 6. The connector on the Cat 5 or Cat 6 is from a size perspective isn't any different. Going back to it though, I have this cable right here. This connector is slid up in there. Before I go to crimp it on, I'll go ahead and just recheck my order. One way to make that easy is to just flip it over, look at it upside down, pull the little catch pin, and you can see all your colors in orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. We have our wires all to the end of this little connector, and we have verified that we have the sheath past that little pinch. Slide this into our crimping tool, and I always kind of grab it with the 2 fingers I have right now. I only say that because that's just what happened accidentally on purpose. I then use this other finger to kind of pull this into this, so I know I'm seating the cable in the end all the way into this while I'm also seating the cable into the connector. And just a little bit of pressure, and I squeeze. Finish squeezing, pull out, pull this little catch, double check my pin out to make sure it's good to go, and we're gonna jump to the other side. Now I know I went through a few little random technical comments there, and there's a whole bunch of little technical jargon in this that I might have already thrown out there. We do have a blog article that kind of covers in depth some of those items. For instance, wiring pattern, the differences between Cat 5 and Cat 6. Feel free to check the description on a link to that blog article. All right, so at this point we should have a good patch cable here, but we don't know that to be true for sure. One thing we could do is we could plug a computer into the wall and cross our fingers and hope everything's good. But it is possible to have 1 or 2 bad pins in a cable and the cable still appear to be good. Technically speaking, on a 10-100 network, you only need 4 of the 8 pins to be working. But anyways, what I'd recommend doing is grabbing some type of tester. I absolutely hate terminating cables and not just verifying they're good, because God forbid 6 months, 12 months later, someone have some kind of trouble and you start troubleshooting. I'd like knowing the network cable is good to go. If I'm ever having some kind of network trouble and I have any doubts, I'll immediately go and check that. But what's the sense of pre-wiring or making patch cables or doing anything like that, not just checking that first layer? Now, obviously, if you want to pick up a tester, there's gonna be a link in the description for this exact one, as well as one like this for that maybe a little cheaper for you guys out there just doing some home projects. But all testers are similar. Sometimes they have this little unit that's just kind of plugged into the bottom so you could pull it out of there. This one actually is a part of a bigger kit where you have multiple dongles. First and foremost, pull the bottom one off of here and plug this into the top. Plug the other end into the bottom. And if you're curious to which ends I knew to plug this into, To be honest with you, the only ones that will work, because this tester will work for RG6, Cat3, and Cat5, or Cat6. So on the other end, you have the same connectors. You have a Cat5 or Cat6 connector, a Cat3 connector, and then an RG6 connector. Once this is turned on, now testers are a little different. So in this particular model, well, let me turn it on first, and let me hit the network jack button, and we're gonna see ID1. This is ID1, so if you're using one of these other little units, it'll tell you what ID it is. So like for instance, ID5. But then it'll give you the order of pins, and as you'd expect, they are pins 1, 2, 3, 4, 5, 6, 7, and 8. If you had a bad pin, something that didn't make the cut, didn't make the crimp rather, or something got cut, you'd either see a pin missing, or you would see, if you had something out of order, you would see them swapped. But in this particular one, we are good to go. So I'll go ahead and make a bad example real quick, just off camera. Okay, so I went ahead and I clipped the green-white wire, not the green-white and green, just the green-white wire, which will tell us that we have a, bad pin 3. So we'll see what this says, because I have a feeling it's gonna say you're missing pin 3 and 6, but we'll see. And there we go. You see we have pins 1, 2, 4, 5, 7, and 8. That's because this tester uses your pairs to test. So what it's saying is that it tried to send a signal on 3 and get it back on 6. The point is it did not make that reverse trip. So I know that it's because my pin 3 is cut or not terminated. But what you see in the situation is that you've got a bad green-white pair. And you don't know if it's green-white or the green, you just know it's the green-white-green pair. And so what you would do from there is you would either look at one of your ends, you either pop this end out, and then try to see if maybe it got pulled back, it's not terminated all the way to the end, you know, something like that. If it looks good, you're gonna check the other end and do the same thing. And unless you find something that's bad, you know, a lot of times it'll be obvious. But if it's not obvious and you made a patch cable, you're dealing with 2 male ends, then what I do is I look at both ends and I make a guess at which one looks less good. And I will re-terminate that end, because that is all you can really do. And if that works, awesome. If not, the other one was probably less good. All right, so I'm gonna go ahead and set up a scenario where basically pins 3 and 6 are just wired backwards. Again, just so you can see that scenario real quick. Task failed successfully. Okay, and what you see here is that pins 1, 2, 4, 5, 7, and 8 are good, but pins 3 and 6 show up as pins 6 and 3, which just means they're reversed, and we can flip them back and we're all good to go. The only way to know which side is bad is with a visual inspection. So in this scenario, just like any others, we're gonna take a look at our ends. We're gonna see what looks wrong. This one immediately looks wrong. I can see my order, and I'm going to cut this end off. I'm gonna rewire it, and that's all there is to it. All right, as you guys see here, we have a couple of wires hanging out of the wall, and I'm sure no one here really appreciates this look. So how can we tidy this up? Well, obviously we want to terminate and pop into a wall plate. For that, we won't use a male end, right? We will not be making the same end we put on a batch cable. We're going to use a little keystone. As you can see, this one's already terminated and done. All we gotta do is put a keystone on this side here, and we can pop this to a wall plate, screw that wall plate onto the wall right here. And the final step, obviously, would be to test to make sure it works. And we will go through that. But first and foremost, I'm going to grab the same strippers we had before. This one, you know, I would be crazy critical about saying that you need to cut it just the right length. We still have to deal with that untwisting. But if we strip too much, it's going to be fine. One thing, I like 12 to 18 inches of cable just coming out of the wall. So if this was not that right now, and that would be about 12 inches, that's more than plenty, maybe a little more, that's perfect. And if it was too long, you could do a surface loop in a box, but I like just having this cable kind of foot, but you can't stretch an inch. So anyways, we're gonna go ahead and strip this cable back, pop that sheath off there, pin these 4 pairs back real quick, snip that center channel. And you don't necessarily have to snip that center channel on this one, right? I just do it because it keeps stuff out of the way. Then we're gonna grab our keystone. And the one thing about this keystone here is, just like every other keystone, they will have some kind of a legend or a wiring pattern, whether it's through numbers or colors or both. Almost all of them have both. And so you have to understand your wiring pattern. As I already mentioned, the world almost always uses B, and I always have patch cables wired in B, so we're going to wire B. I will stop saying that after this. I then look at the colors that are at the end of the keystone. They are not the same for every keystone. Even though there is a standard for the wiring pattern, where they put those pins on a keystone are not always the same. So pay attention to that when you grab a new keystone that you're not used to. What I see on here is blue as far as back on the left-hand side and green on the right-hand side. So I will grab those 2 first and put the other 2 kind of in the middle here. And I'm doing that because we'll just start with green, some green, white pair. Very first pin is pin 3, which is my green, white.
And I'm going to take that wire, kind of hook it there, and then using my fingernails, but gently, I'm going to push it down into that little track until I feel it won't go any further. So I've got that first wire in there. The next one is pin 6, which is my green wire. And so I'll grab it. Now, I'm delicate with the inner channel here. So when I'm using my left thumb in this particular scenario, I'm making sure not to dig my fingernail into it. But on the right side of it, or the outside of this connector, I will force my nail into it. And I'm saying that because if you happen to see in here, I just exposed a little bit of copper there. Now, when we flip to the other side, I will tell you everything I just said in reverse, because what I'm talking about is the difference between the inner side of the cable and the outer side of the cable. So on this side over here, we've got blue, white, and then blue. So we'll grab this pair, spin it or unspin it real quick, and then grab this, and I will grab with my thumb, use my nail. On this inside, I'm being gentle and just to make sure it's tracking, but I'm putting most of my pressure on the outside of it. Same thing with the next side, give myself enough slack. And once I have it lined up, push down. And what you'll see from there, I already have 2 of my pairs, so 4 wires, kind of pushed down on the channel. They aren't officially terminated yet, but I have them down there enough where the whole keystone now will just sit there and float. It'll live. It's not going to do anything. And I've kind of accounted for all the slack I needed in this because I did the pairs at the furthest back end of that keystone. So from here, I'll grab the next ones up, which on this side over here are brown, white, brown in that order. So I'll grab my brown, white, brown pair, grab this one, kind of get it lined up in that groove. I grab this side of it with my nail, kind of pull down on it, and same thing on this end. Now, I've mentioned that a couple of times. It's not critical. If you're just doing one of these, for instance, if you put these cables in here, but you don't set them, you don't kind of get them tucked in there, as you keep going, they'll pop back out. You got to come back and do it again. So I'll take just a little extra half second to make sure they're good and seated in that notch or in that groove before I move on. So I do my last pair, which is orange, white, orange. And you can see they're all kind of tucked in, right? They have a little excess hanging out, but that doesn't matter because we're going to use a punch down tool. And that punch down tool has 2 sides to it. You can almost even see by the red and the yellow of this that they're different things. On this particular one, it says cut right here on the yellow side. And it's aligned with the side of the keystone punch down tool that has a sharp edge or a cutting end. That's very important because the way this works, the cutting edge being on this side, you want it on the outside. So if I have to terminate the other side of this keystone, I need to flip this over and use this side. If you do it backwards, you will terminate that cable down into the keystone and you will cut the cable, but you'll cut the cable off on the wrong side and therefore make it useless. One last pointer, because of this cutting tip and because we want it seated all the way, you don't want to come in at an angle like this because you might do that and cut the cable, but not seat it down against the piece of metal in there that's making contact with. So what I typically try to do, hold it in your hand like this. You can kind of hold it in the palm. There's a bunch of different ways. I just kind of squeeze it, give myself enough space. But I start on the inside at an angle. Come in all the way down, and once I feel it seat, then I kind of push and roll out. Most of these have a little snap, pop, little impact piece to this. And what it does, it goes all the way in and it pops back out. Gives it somewhat of an impact, which helps to break this cable or cut that cable. So I'll punch these next 3 real quick. And then, like I said, start cutting the inside at an angle, push and roll out. Inside of an angle, and push and roll out. And if you get done with these and these cables didn't just fall off when you cut them, when you pull them, either pull them straight out or best to pull some down. If you weren't thinking about it and you went to try to pull out, even though it's disconnected, you might unseat that pin right there. So just be mindful of those things. On the other side, same thing, but don't forget to swap the way your keystone is oriented so that your cut side is on the outside. You start on this inside, get in that groove, push, roll out. And as I mentioned before, these don't fall out or fall off. Sometimes they do. Make sure you pull down and away from the connector so you're not pulling them out of there. A quick little visual inspection. I like to go through and just make sure I see all my cables at the bottom. If you have any of them that are halfway up, I'll either just grab the keystone or repunch, or I'll make a decision on whether or not I was going to pull the whole thing up and re-terminate if I felt it really needed to. All right, so after we have that terminated, we put the little end cap on there. This guy's ready to throw into a faceplate. I always like to test these cables before I actually put them into a faceplate, or at least before I screw the faceplate to the wall. Last thing I want to do is take it off and have to redo it if something was bad. So let me grab my testers real quick and we'll give it a quick test.
Went and plugged this into that keystone, and we're actually just using a patch cable. It was all just for show as it came out of here, but just wanted to make sure you guys were aware that this was no different in the way that you test. You plug this guy into the keystone, and on the other end of the cable, you just plug this in. Now, one thing to mention with the setup, we did this just so you guys could see this testing happen correctly. But if you're in a commercial business, or even in residential, if you're doing it right, as far as I'm concerned, you're not going to terminate to a bunch of male ends back in the closet. You're going to terminate into a patch panel, which is a group of keystones. As a matter of fact, the patch panels that we use are these days actually just empty brackets that you pop keystones into. These cables are going to be mixed in with a ton of other cables in the back. So to find one of these cables, if you didn't just run a single one-off cable, let's assume you ran 100 cables and you terminated all those here at the wall like you see here, and then you terminated all of them into a rack in a network closet where you have a patch panel, and those patch panels are just randomly numbered there. If you didn't do any type of purposeful organization beforehand, then what you have is a patch panel with 100 cables, and you have a bunch of wall plates with a bunch of keystones, a total of 100 cables, and you don't know where they are. One thing I mentioned is having these testers being labeled. If you just had this one, right? Imagine a scenario where you just took this one guy right here, you plugged it in here, and you went to the patch panel on the back, and you took the other side of this tester and you just plugged it into port 1, and you hit the test button. There is a chance that you will not hit anything until you get to port 100 if you're the unluckiest person in the world, and as a result, it's going to take a lot of time. So one way to make that a little faster, as I mentioned earlier, is instead of having just one of these, this particular kit has 6. I used to have a kit that has 8 of them. Now you're in a scenario where you have 100 cables and you have 8 things that are going to show you a hot connection. Still going to take a long time, but what you could do is just terminate the wall plate side here, put tone on that cable, and then find it in the closet. And we use a tone generator. What it does is it just simply puts a signal on this cable that is going to go along the cable the entire way to the back. This cable is basically just going to turn into a gigantic antenna though, so be mindful of that, where some of that noise can be induced into one of these other cables here. So this tester doubles as a tone generator, and this particular one, I just push this little button right here and it starts applying a tone to this cable. This is the wand on the other end that's going to pick up that sound. The one thing you'll notice is that right now, whether or not you hear it, it just picks up sound in the air. If I touch this cable, get closer to it, it's going to pick it up better. Be aware that sometimes that tone being transmitted, especially if it's right here close to the tone generator itself, will be a lot louder than you'd expect, and it may not help you identify the cable. Now, another thing is, it's usually generating this on a particular pair or a particular pin. So if I roll this cable around, there's a chance that I will hit that particular pin, and it'll get louder. All right, so we went ahead and put tone on this. We're gonna go to the closet in the back and see if we can find this particular wire. Now, one thing to be mindful of is that if this is terminated into a patch panel, no big deal. But if it's terminated into a patch panel and then is plugged into a switch, there's a good chance that switch is grounding this tone in the end, and so it may be hard to hear. Some switches are different than others, and they do a better or worse job of this. But if you're terminated into a PoE switch, there's even greater of a chance of it grounding that tone out. And so if that's the case, when you get to the back, you may not be able to find it. And one easy way around that is pull the power to the switch. Sometimes you might even have to pull the power switch and actually unplug every single cable individually. So just be aware of all that if you're trying to do this in a live environment. To unplug a power to a PoE switch, for instance, may take everyone's phones down, may take security cameras, access points down. So anyways, let's go ahead and sneak to the closet in the back real quick and see if we can find this cable. All right, so we put tone generators on the other end there. We come back to the closet, and you can see all of these cables back here. I popped off a couple of patch panels and started skimming through, and kind of wasn't finding it at first. Got worried I was gonna have to pull power to a switch, as I mentioned earlier, because it might have been grounding out the tone. But I was sweeping across here, and there it is. So you see that I could just hold this thing in the air close to the tone generator at the other end, and it was making noise. But you see over here, much different scenario. So you really have to hit that cable. And I found it right here. So like I said, it's actually putting that output on a particular pin. So if I just don't simply roll around and hit the right part of the cable, it might not be as strong as it is on the other side of the cable. So exact same cable. On the other side of the cable, it's supposed to be where I'm closer to that pin. But so let's pull this guy out of here real quick. Go ahead and touch up in this port. And yep, that's it. So If you want to run testers on this, now we can go ahead and plug in our testing on both ends because we've identified what a cable. So there is always a chance that you can have a really bad experience, and by that I mean tone generators do put that output over a particular pin or pins. And so if you had a cable and the whole goal was to test whether or not that cable was good, and you're back here trying to find it, and you're putting tone over that particular pin, but that pin is the one that's bad, it may not be something that's very obvious. One thing I kind of do to troubleshoot that, if I kind of run into a scenario where I can't find a cable, as I mentioned before, I'll pull power to switches, I'll unplug patch cables from the switches if I feel like the tone's being grounded out. But one other thing I may do is just go further up your cable, whether it be on this end or on the other end, and keep touching that line and make sure it's actually applying tone to that line. So since we know this is the right port, we're technically done with the tone generator part of this. This is doing nothing more than applying a tone so we can find the cable, right? But now we want to actually test, verify it works. So we go back to the testers. Plug a tester into the wall side and plug a tester into this side, hit our test button and make sure all 8 pins show up in the order we expect. Okay, now that we have all of our cables terminated and we have tested them, we know they are good to go, we want to go ahead and pop them into a wall plate. In this particular scenario, we actually just have 2 separate Cat 6 cables. As you can see here, one of them is white and one of them is black. That is something we do internally so that we can kind of do a pre-sort in the back. So for instance, and it depends from job to job, depending on how many wires we have or the type of cable we have, but we'll use white for phones. Does it matter whether it's white or black because it's phone or just general data? No, but in the back, when we have 100 cables, going back to that example, if we have 40 of one color and 60 another, we already have a nice pre-sort done, and we do typically put phones onto a PoE switch where we put general data into a non-PoE switch. And so we will pre-sort them like that just using color. We had more than 2 cables in here, we had 3 or 4 cables in here. Most likely we'd probably still have a single PoE and we just have multiple of these. Maybe we need a network-based printer or some other network-based object that again doesn't need PoE. In that scenario, I will stack these in the same way that I used to stack phones. This particular wall plate is just a 2-port wall plate, right? And these keystones pop in here. To try to run a tone generator and find those every single time is annoying. Now obviously you can label the patch panel in the back, you can have a little wiring diagram, you can do all kinds of things, but one thing that some people do is write which particular jack this is. I don't like the look of that, and unless we're in an environment big enough where it's necessary, I typically don't do that. But one thing I will do is I won't pop these into here, into this faceplate randomly. Phones are always on top. That's just standard that I made up for myself, but it seems that everyone else agrees. Whenever I'm explaining this to someone, I'm trying to think of all kinds of silly analogies, and one of those things is just a pyramid, A pyramid, it's wider at the base. Well, when you're using Cat 5 or Cat 6 cable, it's a wider connector than a Cat 3 connector. That analogy breaks down these days because we use PoE phones, but whatever it may be, have a convention, right? Even if there's no reason, there isn't a convention for you to adhere to. If you're wiring your own house, your own business, unless you want to have a bunch of stickers everywhere and a bunch of charts to remind you of what you did, just do the same thing at every spot. Consistency is key there, right? So one last thing, when you're popping these in here, the way this works is that they go into the bottom and pop up. This keystone kind of sits in the bottom and rolls up and in. That being said, some of these keystones, or some of these wall plates rather, have more space than this one, and what I'm about to say won't matter as much, but always put the top keystone in first. Why do I say that? Well, if you put this bottom one in, you already see, and I won't pop it all the way in because it's going to be a pain in the butt, it's going to be hard to get that same angle I was just showing you. But if instead you start with the top one, you can kind of hook the bottom, pop it in place. Grab the next one, hook the bottom, pop it in place, right? And so now you have both these popped in place nice and flush. Take this little bit of slack we have and just coil it up into a little bit of a service coil there, and grab our screws and tighten it up. So after this is terminated to the wall, assuming you tested everything and everything tested good, then as long as you put a patch cable in the patch panel in the back network closet and connected it to your switch, or however you're connecting to your switch in the back, these jacks will be hot and ready to go for anyone who walks in here and just wants to plug something in. Last thing, now that this is on the wall, obviously the most important thing is like and subscribe. So catch us in our next video and we'll see you there.